Greetings, Earthlings. What you see here is a Racal Dana 9009 N modulation meter. I thought we'd look at something a little different today, rather than, well, I mean, it's still test equipment, but it's not vintage computing, and it's not a multimeter. It's a modulation meter, and it can measure FM or AM modulation up to 150, well, kilohertz on FM or percent on AM. Covers the FM broadcast band, which is why I have it. And so, but I've had it about 20 years, haven't used it in quite a while. Just took it out of storage, and so I want to see if it still works. So I've set the, I've got my Racal DG822, which thinks it's a 922 over here, outputting at 88.1 megahertz, which is the bottom end of the FM broadcast band, at least in North America, and set for FM modulation of 1 kilohertz frequency and a frequency deviation of 100 kilohertz, which is actually more than 100%. Plus or minus 75 kilohertz would be 100% modulation for broadcast. But that's okay. I just want to see how well it reads. So I've got it set here on the 150 range. That is a switch, and there. FM, measuring peak. It shouldn't matter. I've got an audio frequency filter in, auto and power on right here. Oh, you know, this has an optional battery pack, but I don't have the battery, so battery check doesn't do anything. Okay. So we'll watch the light and see if it locks. Indeed, it did. So it's, golly, it's still working. I'm trusting that this meter is accurate on its deviation, which means that it's reading a little high there. And if I flip it down to the 100 range, yeah, it's a little high. Okay. Right around there. Okay, so that's 93 kilohertz. Yeah, it's off by, what, we can call that 7%-ish on that end of the scale. If I bring it all the way down, 1 kilohertz frequency deviation, and we would go to the lower scale. Okay, that's on full scale of 10. That actually reads fairly close. There's full scale of 3. And 1.5, which is this scale here, which is that scale there. It still reads a little high. So this needs to be calibrated. Yeah, so let's open it up and have a look inside. I have the manual for the 9009, which is not quite the same. It's slightly different ranges. It only goes to 100 kilohertz or 100%. And, but otherwise, very similar, so that should be good enough. I hope that the calibration procedure, which is in there, will work on this. Let me switch off, and we'll get it opened up. Well, so I didn't show it. There's 2 screws on the side to open this thing up, and so you undo those screws, and then this slides back a bit, and it has a top and a bottom cover, and they just lift right off. That's obviously the bottom side of the board. The top cover gives access to the bottom side of the board. Okay, 1982, it says there. It's presumably when this was built. There's the bottom, which is the top side of the board. Let's have a look. Oh, that's pretty. You see that? Now, what do I see here? There's something interesting right here. Someone has put an hour meter in this, and I'm looking at it, and it's totally blown beyond recognition. So let's see. That is. It has operated for more than 5,000 hours. I don't know if they used that as an indication of when it should be serviced, or calibrated or something. So there's a few integrated circuits in here. See a lot of tantalum capacitors, those little blue guys here. What's that? What's that? There's an electrolytic. And I can see, this isn't going to show up on camera, but there's an electrolytic right there. Now, that's the only electrolytic I see in the whole thing. Probably the power supply. Well, yeah, okay. But on the main board here, in the main circuitry, it's all tantalums. There's one 47 microfarad, it looked like it was 47 microfarad electrolytic, and it has puked all over the board, and so I'm thinking that probably originally was a tantalum, and that the tantalum blew up, as tantalums sometimes do, and it was replaced with an electrolytic, which subsequently blew up. So I'm going to go ahead and replace that, even though the thing appears to be working. I've got, oh, what was that? Okay. I've got a couple of tantalums here. Oh, no, those are 22s. I'm sure I had some 47s. Okay. There we go. 47s. You can see they're much larger than what's in there because they are higher working voltage. These are 25 volts. So that's going to have an adequate margin. Yeah, there's also, I have some 22, 35 volt. This has a couple of 22s in it, which also see 10 volts. So I'm going to go ahead and replace those anyway, just to be safe. And we'll proceed from there. All right, yikes. I didn't look very closely. That first look, there were actually 5 electrolytic capacitors, all 47 microfarad, 16 volt, that replaced tantalums. They had replaced them. And so I looked at the schematic, and I determined that, these 5 should be replaced. And by golly, all of them had been replaced with electrolytics. They all measure bad. They measure like 3 microfarads, 1 microfarad. Nothing in even double digits. There were 2 others at 22 microfarads, which I decided I should replace. And they actually measure okay, except one of them, there it is. So this one was exactly what it claimed to be. It was a 22 microfarad 16 volt. And I replaced it with a 22 microfarad 35 volt, because that's what I had. This one, which on the schematic says it's 22 microfarad 16 volt, actually had a 47 microfarad 6.3 volt capacitor in it. I'm surprised that didn't blow up. Because it sees 10 volts. There's a resistor in there, but it does see 10 volts. Okay, we're back. 1 kilohertz frequency deviation on should be 88.1 megahertz still. Yeah, this has automatic frequency, obviously. So let me turn that on and we'll see if it locks with the, yeah, hey, how about that? With the proper, with good working capacitors, okay? 1 kilohertz, well, it's reading above 1. So we will want to adjust that. And, no. Come down here. Give it 100 kilohertz. I will go to the 150 range. I'll give it 100 kilohertz, which should be right there. And again, it's over. Yeah. So I will attempt to adjust this, and we'll come back. All right, so here it is, all calibrated as best I could and back together. What I've got right now is putting out 88.1 megahertz carrier, modulated at 1 kilohertz, plus or minus 100,000. So this is on the 100,000 scale. You can see now that is reading right on full scale. And over here, there's a DC output on the back, and it's supposed to output 1 volt at full scale. And so I had to adjust that, but that's also now correct. So I can adjust this now. If I go to 50, if I go down to 50, you can see that that's still, you know, reasonably close. And 30. Now at 30, I can switch to another scale, but you can see where it's at. And I can switch to that scale, and we're reading now here, and so that also looks correct. So we're going to go back to the 100 scale. I'm going to set it to 75, which would be, now that's 100% modulation for the FM broadcast band, okay? And to have, let's get this out of the way, I have a modulation meter here. Well, modulation, shall we call it an indicator? An analog gauge, which can measure modulation. I've got a calibration control there, in case I need it. But I know I won't. Okay, so there you can see at 75 kilohertz, which doesn't read exactly 75 here. It's reading a little low here, but I can calibrate that to read 100%. Okay, knowing that it's 75 kilohertz in. Okay, so that now leads us to our next little fun test. Okay, here we go. This is a little FM transmitter. It puts out about a watt. It's operating into a dummy load, so it only broadcasts maybe across the room barely. But I've got a clock radio sitting right next to it, which can pick it up. This box contains a stereo generator and a limiter, and that's fed from a CD player which is playing Peter Wolf CD. Only this is not hooked up right now because I wanted to show. First thing you would do is, oh no, that's not gonna work. That's not gonna work at all. I was gonna show Stereo Pilot, but I can't do Stereo Pilot without having the output of this thing hooked up. But when I hook that up, you can see it moves. And I turn this on, Rosie.
All this time, I found myself still thinking about you, Rosie.
Okay, so let me give it 0 input. Now you see there is still some modulation. If I flip this down, now I'm reading 10% full scale instead of 100%, which shows the stereo pilot is about 7.5%, which is maybe a little on the low side, but still adequate. I'd have to open this up to change that, to make an adjustment. But so here you go, operating at 104.1. So my Racal only goes to 100 megahertz. This covers the whole FM broadcast band. So I set it to 104.1 in honor of WBCN, where actually Peter Wolf worked. And before he started, well, it was one of the founders of the Jay Giles band.